Look across the room at someone right now. Their eyes flick for a fraction of a second toward the window, then back. You saw it. You knew exactly where they looked, and without thinking about it, your own eyes followed. You cannot do that with any other animal on Earth. The white you see in human eyes is found in no other primate on the planet. Hundreds of species of monkeys, apes, and lemurs have been studied. None of them have it. Most people assume your eyes are white because that is just what eyes look like. And the real answer is far stranger than you'd expect. Your eyes evolved to give you away. The first piece of the puzzle is anatomical, and it took until 1997 for anyone to map it properly. In 1997, two researchers at the Tokyo Institute of Technology, Hiromi Kobayashi and Shiro Koshima, published a paper in the journal Nature titled Unique Morphology of the Human Eye. They had photographed and measured the eyes of more than 80 primate species: gorillas, chimpanzees, bonobos, macaques, lemurs, tarsiers, every primate they could get a clean image of. Then they compared. Every other primate had pigmented sclera. The white of the eye matched the skin around the face: brown, olive, slate, colors that absorb light and disappear into the face. In a chimpanzee, you cannot easily see where the iris ends and the sclera begins because there is no white. You cannot tell from a few feet away exactly what direction a chimpanzee is looking. Try it sometime at a zoo. Stand in front of a chimp at the glass. The chimp is intensely aware of you. It is tracking everything you do, but you cannot tell where it is looking. Its eyes are a wall, but in humans, the sclera is white, bright white, visible across a room. The contrast between your iris and the tissue around it is, on average, 18 times higher than in any other primate they measured. You are looking, right now, at the most readable eyes that have ever existed. But here's what's fascinating, because making your eyes that easy to read is, in evolutionary terms, a terrible idea. Imagine a chimpanzee in a competitive feeding situation. Two of them spot a piece of fruit at the same moment. The one whose eye direction is harder to see has the advantage. The other does not know which way it will lunge. Imagine an ancestor stalking prey or scanning the trees for a predator. An animal that broadcasts where it is looking gives away its intention before it acts. Pigmented sclera is the default for a reason. Almost everywhere in the animal kingdom, eyes are camouflaged. Snakes have slit pupils. Cats have vertical irises. Birds have hard, opaque eyes. Even crocodiles have a third lid that hides what they are tracking. So why did one species evolve in the opposite direction? In 2007, developmental psychologist Michael Tomasello at the Max Planck Institute for Evolutionary Anthropology in Leipzig published the answer in the Journal of Human Evolution. He called it the cooperative eye hypothesis. Humans evolved white sclera, Tomasello argued, because we cooperate, we hunt together, we raise children together, we share food, we teach each other things our ancestors did not know how to do, and every one of those tasks gets easier when you can see what the person next to you is paying attention to, at a glance, without asking. The whites of your eyes are not a flaw, they are a billboard. Your ancestors broadcast their attention because attention shared is the foundation of every cooperative thing humans have ever done. Think about what happens when you point at something. The other person looks at your finger, then at your face, then they trace your line of sight back to whatever you wanted them to see. The whole loop takes maybe 2 seconds. It works because they can see your eyes. Try the same gesture with a chimp. The chimp will look at your hand. It will not understand the connection between your gaze and the thing you are pointing at. Tomasello tested this. He set up experiments in which great apes and human infants watched a researcher whose head and eyes moved in different directions. When the researcher kept their head still and moved only their eyes, the apes did nothing. They did not register the eye direction at all. They followed the head, or they did not follow anything. 12-month-old human babies followed the eye direction every time, even when the head pointed somewhere else. A child with no language and no education knew that other humans were broadcasting where they were paying attention. The white of your eyes is a signal so strong that an infant can read it before they can speak. Watch a 6-month-old in their parent's lap sometime. The baby studies the parent's face for hours. Not the mouth, not the hands, the eyes. They are learning to read the whites of those eyes the way you learn to read the alphabet. By the time they can walk, they can track adult attention almost as well as you can. They are taking lessons your ancestors built across hundreds of thousands of years and absorbing them in their first year of life. But that is only part of the story. And honestly, what your brain does with this signal is even stranger. In 2004, neuroscientist Paul Whelan at Dartmouth College published a study in the journal Science with a result that surprised even his own team. He showed subjects images on a screen for 33 milliseconds. About a third of the time, it takes you to blink, so fast that the subjects had no idea anything had been shown to them at all. Each image was immediately covered by a neutral image, a technique called masking. The subjects' brains were scanned the entire time. The hidden images were of human eyes. Some showed the wide, fearful sclera of a frightened person. Some showed normal eyes, with little white showing, of a calm person. The subjects could not tell by their own report that they had seen any eyes at all, but their amygdalae, the brain regions that handle threat detection, fired in response to the fearful eyes every single time. You read the whites of other people's eyes whether you know you are doing it or not. Your brain decodes their direction, their fear, their attention, all of it in less time than your conscious mind takes to register that anything has happened. This is why, walking down a street, you turn around when a stranger has been staring at the back of your neck. This is why you can sit in a meeting and know, without anyone saying a word, who in the room is uncomfortable. This is why a baby's eyes lock onto its mother's eyes from the first weeks of life. The whites of your eyes are a communication channel that runs underneath the rest of your brain. It is also why eye contact in almost every human culture carries more weight than any words layered on top of it. You can lie with your mouth, you can lie with your hands. The whites of your eyes are harder to fake, and here's the part nobody talks about. Sometime between 30,000 and 15,000 years ago, somewhere in Eurasia, wolves started living near humans. They scavenged at the edges of camps. They ate what the humans threw away, and the ones that survived best were the ones that did not run from a human gaze. Over thousands of generations, those wolves became dogs, and along the way, something strange happened to their eyes. In 2015, a team led by Takafumi Kikusui at Azabu University in Japan published a study in Science titled Oxytocin Gaze Positive Loop and the Coevolution of Human-Dog Bonds. They measured oxytocin levels in dogs and their owners before and after 30 minutes of mutual gaze. In both species, oxytocin went up. The dogs locked eyes with their humans, and both nervous systems released the bonding chemical that mothers and infants release when they look at each other. The same chemical your nervous system releases when you gaze at someone you love. This loop, oxytocin released by mutual gaze increased by oxytocin, runs in human babies and human partners. It runs in mothers and infants across primates, and it runs in dogs and humans. In no other interspecies pairing that has ever been measured, when wolves became dogs, they didn't just become tame, they were selected, generation after generation, for the ability to lock eyes with us. They evolved into the only animal on Earth that can read the whites of human eyes the way another human can. In a separate set of experiments, the comparative psychologist Brian Hare showed that dogs follow human pointing and human gaze better than chimpanzees do, better than wolves do, better than any animal that has been tested. A puppy that has never met a human before will, on its first attempt, look in the direction a human points. First try, a wolf raised by humans from birth still struggles with the same task. This is what white sclera built, not just the Cooperative tribe, a species you let into your home. So look across the room at someone right now. Their eyes flick for a fraction of a second toward you, then away. You see it. You always see it. 60 million years of primate evolution decided to keep the eyes hidden. Then, somewhere on the African savanna, a small group of apes decided the opposite. They evolved eyes that could not lie about where they were looking. They built tribes around it. They raised children with it. They invited a wolf into the firelight. You inherited those eyes. Every time you meet someone's gaze, you are running an ancient broadcast system underneath your conscious mind, and the message it has been sending since the beginning is simple. I see you. I am willing to be seen.